is for you.
Good morning, Mr. Davis. Or, yep, it's the morning.
Good morning. No. Well, if you like to, your own time.
Oh, I remember how to do it. I like doing it.
Gift on your desk. It's not for me. I would never get you a gift.
I'm gonna marry
Do this, please. Find the derivative. So there's your first step if you want to check that you did the first step correctly. Make sure you remember to reduce the power by 1 here and not like eliminate the power. Make sure you remember the chain rule, like the extra multiple. Same thing here, make sure you reduce the power by 1. Oops. And then remember the chain rule part. from there, your job is to pull out the chunks so you get all one term. So like the reverse distributive property thing. So then we'll go over one with negative exponents, and then we'll get into like the fraction exponents that we didn't talk about yet. So from there, I would take 3 of the 2x minus 5s, put them in front, 2 of the 3x minus 4s, and put them in front, and then I can knock off, there'd just be one of those now, none of those, none of those, and one of those. And then it's just a matter of kind of cleaning up the inside. Questions up until that step? I'm not done yet, but I'm close. Questions getting here? Yeah.
You've written 2x minus 5 is squared.
Oh, thank you. Actually, I remembered now the one with the derivative. That's weird. And then we're just going to simplify the inside part here. So this would be 18x squared minus 45. This would be 48x squared minus 64x. So I have 66x squared minus 64x minus 45 on the inside. What do you got for that answer? Questions I can help with? Where'd you get this? Where'd this come from? It's only 3 steps. Just feels like a lot. Can I go on to the next one? Alright, so let me give you a negative one. Review that again. Wait. And then we'll get into the fraction stuff. We'll just do one of them negative this time. We did both negative every single time last time. So we didn't do one like this. That was one like this in your homework. Product and chain, and then get rid of the negatives. You'll have 2 fractions. We want to combine them. So that's where you should be up until there. That's what I'm learning. Let's just ignore it. Fair enough. Yeah, so there's kind of two ways to finish this. Like when you get to the end, you could, but it would just depend on what the AP test did. You have to look at their multiple choice answers and see what they went with. You could square this. Remember, a binomial is part of the trinomial, though. And expand it all and come out all the like terms up top. But you could also do like we do with the other product rules and take this chunk and pull it out in front. So you can kind of go either way with this one. But I do need to fix the bottom first. So if I got 4 of these here and 3 of these there, I need another one of these over here. And then I need another one of those on top. So to me, it'd be easier to take one of the x squared plus 4s and put it in front, leaving me with negative 9 times x squared plus 4 plus 4x times 3x minus 5 on top. All over that stuff on the bottom. You see what I did there? So this is my new top, basically. And it's certainly okay if you squared this and combined all the like terms. Like that would work. That's not wrong. I'm trying to make my life a little shorter. That's not bad. I'm not trying to make my life shorter. I'm trying to make my life a little easier by saying, okay, there's 2 chunks of these here and 1 of them there. So if I pull one out in front, now there's just 1 there and there's none there. And then I can simplify that top stuff here. So this would be negative 9x squared minus 36. This would be 12x squared minus 20x. So with the x squared plus 4 out in front, I'll have 3x squared minus 20x minus 36 on the inside. And then the 3x minus 5 to the 4th on the bottom. And then so if you did it the other way, you would get, like if I took and multiplied all that crap out, you'd get a different looking answer, but the same answer.
So that's the same idea as like on the homework.
Yeah.
Because I got us
Exactly.
to the like common denominator, then I didn't know what to do at the top.
So yeah, the same idea as the homework. Does that make sense? What I did?
Yeah. The second like bracket part, the red. Oh wait, I didn't see the first row. Oh, okay, that's what happened. And that second was just simplified.
Yeah, just like cleaning up this stuff. Are you good?
Yep.
Any other questions? Why did you do this? Where did this come from? Somebody had that. Or like maybe in a different form, but you had that idea. Okay. Alright, let's look at what if it's fractions. This gets a little bit more. Again, the calculus is not the hard part here. It's the algebra. This would be number 3, right? So let's say 2x minus 3 to the 1/2 times x squared minus 4 to the 2/3. So again, that's product and chain, right? So I have a function with an x times a function with an x. 2d1, 1d2. And when I do the derivative parts, it's got to be chain rule. So the second thing is x squared minus 4 to the 2/3 times the derivative of the first thing. So bring down the 1/2, multiply by the inside, reduce the power by 1, multiply by the derivative of the inside. So this is the chain rule for the first part. This goes to this. And then flip-flop it. So plus the first thing times the derivative of the second thing. So drop down that 2/3. Leave Mr. Packard alone. Reduce the power by 1. Multiply by the derivative of the inside. So now I don't want negative exponents. Well, I should stop there though. Questions on that first one? Yeah. So now I'm going to get rid of negative exponents. So I'm going to start making fractions out of each of these pieces. So this right here kind of sets up my fraction for me. I'm going to go 1 on top, 2 on the bottom. Okay, I've taken care of that. I got this 2 over here, which I'm going to put on the top. And at this point, wouldn't my life be a lot easier if I, not shorter, easier, if I just knocked off those 2's? Okay, they're just not there. I mean, basically, what did I just do? I said 1/2 times 2 is 1, so I don't really need to write the 1. Right? Just canceling those out. And then the x squared minus 4 to the 2/3 goes on top. And the 2x minus 3 to the 1/2, it's a positive 1/2 now, goes on the bottom. Plus, so again, this kind of sets up my fraction for me. This time nothing will cancel. So I got 2/3. I've got another 2x up there. And I've got a 2x minus 3 to the 1/2. And then I've got an x squared minus 4 to the 1/3 on the bottom. So that's just rewriting it. I didn't like get common denominators or anything yet. Yeah.
Where did you get the 2/2 from on the first one?
So the 1/2, I started off with a 1/2. It was 1 on top, 2 on the bottom. And then this 2 came up on the top, so now it's a 2/2. And now they just go away. You good? Anything else? To there. Alright, now it's time for the common denominator fun. So the first thing I would probably do is the 3. If I've got a 3 on the bottom over here, I need a 3 on the bottom over here. Well, that means I need a 3 on the top up here also. So what did I really just multiply this entire fraction by? By 1, because 3/3. But now I've got this other, so let's say I had just like off to the side, let's say I had 2/7 plus 5/6. What would your common denominator be here? It'd be 42, so you have to multiply this one by 6/6, and this one by 7/7. right? Same idea, it's just with, instead of 6s and 7s, it's a bunch of other crap. So what do I need to be to have on the bottom over here? Well, I need x squared minus 4 to the 1/3. The nice thing is it'll always work this way. I need an x squared minus 4 to the 1/3 on top, right? So at first you kind of freak out. You're like, crap, I have fractions on top and powers, and it gets all goofy. But it doesn't. It never does. Because how many of those do I really have on the top now? 1. And because of the way derivatives work, like you're always subtracting 1 from the power, you're basically just putting it back, and it'll always end up where these just kind of become to the first power, and you won't get the fractional exponent on top. So now I just have 1 of those on top, which I'll do in a second. Same thing on the other side. What do I need to have on the bottom over here? 2x minus 3 to the 1/2. Well, that means I better put 1 on top too, and at first you're like, crap, that's going to be complicated. But it's not, and it never will be, because these will always just give you one of those things. So what I end up with is 3 times x squared minus 4 to the first, so just x squared minus 4, all over just all that crap on the bottom, which you just get sick of writing. Over here, I'm just going to combine those two and make that 4x, and then I have 2x minus 3 just to the first power. All that same crap on the bottom. You guys with me? You see what I'm doing? Again, I don't think this is terrible at any individual step, but we're just creating like more and more chances to possibly make a mistake. You just got to be really careful.
This might have been you were blocking the screen for about half the time, but how did you get that down?
You might want to move.
Yeah, think about it. How did you get down to the x squared minus 4? Just the 3 times the x.
So the 3 just drops, and then I'm multiplying these together, so what do I do with those two powers? No. Like, what's x squared times x to the 5th?
No, x to the 7.
Yeah.
So, yeah.
Add. And so there's just one of them. And the same thing here. So when you're multiplying the bases, you add up the powers, so you just have one of those now. And that's what I was saying, like, that'll always happen just because of the way the derivative works. Your top won't ever be like a fractional exponent. So then if I distribute, I'm going to kind of talk through it so that I'm running out of room. So I get 3x squareds. How many x squareds do I have there? 8, right? So I have 11x squared. Minus 12. And minus 12x. And I'm just going to say over that stuff. I think you guys get the idea. So, I'm going to have you do one in a second so you can practice it. But what can I go through before I have you try one? Where'd you get this? Why did this happen? Seem reasonable? Can I go to the next screen, or is everybody still writing from here? Alright. And then we got to get into what if the fractional exponents are negative. What'd you say, Naomi?
I said let's not.
Thought you liked math.
I do.
Not that bad. Really not that bad. Not even. Eventually, but not right.
I can find it.
Just remember, quotient rule and chain rule is something else. Flip day, you take a fraction, which would create quotient rule. It makes it pretty hard. there's your first step. There's your 2, D1 plus 1, D2. So you might want to check that before you keep going. That'd be annoying if you did all the rest right, but screwed up the first part. So, 3/5. So that's up by fraction for me. This has got a positive exponent, so it stays on the top. This has a negative exponent, so it goes to the bottom. And the 2x has a positive exponent, so it stays on top. I'll leave some space because I know I'm going to have to adjust some stuff. 1/3 sets up my fraction for me. X squared minus 2, the 3/5 goes on top. This 2x plus 5 goes on the bottom because the exponent's negative. And then the 2 goes on top. So I don't need the 1 here anymore. It's not going to hurt, but. Questions getting to that part. So now we got to do common denominator with the number and with the stuff in the parentheses. So with the 5 and the 3, what do I need? I need that to be a 15, right? I gotta multiply this by 3, which means I better multiply the top by 3 also. So now that's a 15. Gotta multiply this by 5, so multiply the top by 5 also. So now that's a 15. That's just taking care of the numbers part. Then I gotta worry about the chunks. That should be positive right there. So what chunk do I need over here? 2x plus 5 to the 2/3. Well, if I put 2/3 more of them on top, what's going to happen to that 1/3? It's really just a 1 now, right? I had 1/3 of them up there. I put 2/3 of them more. So now I have just a regular 2x plus 5. So I don't even really need that power anymore. Same thing over here. I need an x squared minus 2 to the 2/5. Well, I had 3/5 of them on top, so when I go to put 2/5 more, how many do I have now? Just have 1. And then it's just a matter of simplifying the top. So the hard part's done. I just got to clear up the top a little bit. But questions on up until there? Scares me that there's no question. I don't know if you guys just want to ask or everybody's just getting it. I hope everyone's getting it. Alright, so if I start multiplying here, 3 times 3 is 9. Hey. Okay. Yeah, no need toward that. Yep, thanks. Nathan, go to the office at the end of the hour. Alright, so 3 times 3 is 9, times 2x is 18. And then if I distribute that, that's going to be 36x squared plus 90. This is 10 times x squared minus 2, so 10x squared minus 20. So if I combine all that stuff, I get 56x squared plus 70. Oh, you guys got? All over. So now this is 15 times all the other stuff. How many got to that answer? That is the most annoying part of these. If you do all the calculus right, then with you're 2 blocks from your house and you get into an accident. Right. Yeah. Another one? What?
No. 15 should be 18x, so then it's 90x.
Oh my goodness. I lost focus. So yeah, this should be.
Well, you did
Yeah, I did it with that. So that's 36x.
It's not the 90.
So 90x. So it's 46x squared plus 18x minus 20
90x.
plus 90x minus 20. Jeez. How many have that? I cannot read. Questions on it? Alright, let's run through one where I'm not even going to do the whole thing just because of time, but let's just run through one. Let's say it was set up like this. So, quotient rule and chain rule suck together. You do not want to do quotient and chain together unless you absolutely have to. So, 2 things I got going on here. One is I got to get rid of those roots, turn them into powers. And 2 is I don't want a fraction. So, I'm going to write the 3x minus 5 to the 1/2. That's a square root. And this is to the 1/3 on the bottom, so I'm going to bring it up and write it as the negative 1/3 on top. Alright? Now, product and chain. So it just looks a little different when you get down to the common denominator part. So the second thing times the derivative of the first thing. So 1/2. Leave Mr. Packard alone. Negative 1/2 times the derivative of Mr. Packard. So 2d1 and then 1 d2. So bring down the negative 1/3. Leave the little guy alone. Reduce the power by 1. Multiply by the derivative of the inside. So the process is the same. I just want to show you because the common denominator part looks a little different, so I just want to run through one example of that. Questions on that first step? Okay, so 1/2 splits it for us. I'm not going to write the 1 because I'm going to have other stuff up there anyways. This 3 goes on top. Now I've got two things on the bottom now. So x squared plus 4 to the 1/3 and 3x minus 5 to the 1/2. And then over here, so I've got a negative. I'm going to go negative 2x on top and 3 on the bottom. So I'm just taking those two and combining them and going negative 2x on top, 3 on the bottom. We good there? And then the 3x minus 5 is on top to the 1/2. And the x squared plus 4 is on the bottom to the 4/3. So I got two things I got to take care of for my common denominator. Well, I got three things actually. For the numbers, what's the number that's going to be the common denominator at the bottom? 6. So I need to multiply this by 3, multiply this by 3, multiply this by 2, multiply this by 2. So I'm getting the 6's the same. And then I've got 1/3 of these x squared plus 4's here. I've got 4/3 of them here. So how many more of them do I need here? I need 3/3 more, right? Wasn't 3/3 just 1? So I'm going to put 3/3 more here. And that just means I'm putting one of them. So I'm just going to put 1 on top. Is that part okay? And then the other one, what do I need? 3x minus 5 to the 1/2. Well, if I put another 1/2 on the top, how many are there now? Just 1. And then the rest, I'm not going to go through the rest of it right now. I just want to show you like this little part of the setup here because it's a little different than a couple that we've done. So questions on that? I like these. It's good. I kind of like one of them. So you should be able to do every problem on that sheet. So you had the sheet last time with 1 through 10. We did like 3 of them. Do the rest. We got not very much time now with this stuff. So do the rest. Come to me with any questions tomorrow. We'll go over whatever you need to go through tomorrow, and then we're going on to. I think we'll start trig tomorrow. Trig derivatives.